For functions of multiple variables, the term continuity has basically the same role as what we saw its role for functions of only one variable. So if the limit as xy approaches ab for a function of two variables f of xy is equal to f of ab, then we say that f is continuous at the ordered pair AB. Additionally, if f is continuous at all points within an open region, we'll call that open region D for domain, in the xy plane, we say f is continuous on the domain D. Now, typically, most of the functions that we deal with are continuous everywhere within their own domain, so finding where a function is not continuous would be simply a matter of finding where the function is undefined. So for example, let's determine the region of continuity for f of xy, oops, oh boy, there's that one variable mindset coming back to bite me in the butt. X squared plus y squared over x squared minus y squared. Now, obviously there are going to be some domain issues associated with something that has a denominator. So what we can point out is that this means that x squared minus y squared cannot be equal to 0. And factoring that difference of two squares tells me that x minus y and x plus y cannot be equal to 0. So that tells me that y cannot be equal to x and that y cannot be equal to negative x. Within the xy plane, similar to what we saw for the domains of the previous section, this means that the domain of this function will include all of the xy plane except for the lines y equals x and y equals negative x. In what is undoubtedly a delightful irony, this region does look like a giant X. So the domain is the portion that I have shaded in. The dashed lines indicate a lack of equality.